So, in the last class we discussed about the molecular masses. Today we are going to discuss about the mole concept. Okay. So, now let us see what is meant by the mole. So, here you see mole means what? Mole concept. Okay. A mole is a substance, actually mole, how can we define as? A mole of a substance is the amount of substance which contains the same number of particles that are present in 12 grams of carbon 12. The meaning is what? If we are taking, so if you are taking carbon, we are taking carbon, and you know that carbon atomic number is 6 and mass number is 12. Yes, we can write carbon 6 and 2. What is the meaning of this one? The meaning of this one is, this is the carbon and its atomic number, which is denoted by Z, is equal to 6, and mass number A, which is denoted by A, and it is 12. Yes. So, this is the carbon. Now, what we are doing? We are taking 12 grams of carbon. How many grams of carbon? 12 grams of carbon. So, now we are taking 12 grams of carbon. Okay. So, we can write C12 like this, we can write actually. So, that is 12 grams of carbon. When we take this 12 grams of carbon, and in that term, if we count the atoms present in the 12 grams of carbon, if we count the number of atoms, carbon atoms present in 12 grams of carbon, okay, then we say that the number of atoms present is 6.022 into 10 to the power of 23 carbon atoms will be there in that. How many atoms will be there? 6.022 into 10 to the power of 23. Okay. So, the meaning is what? What is this 10 to the power of 23? So, we can write like this 6.022 into 10 to the power of 23 is, you know. So, we can write like this into 10 to the power of 23. 10 square means what? 10 into 10 means 100. 10 cube means what? 10 into 10 into 10, that is 1000. So, like this, here 10 beside means 1 beside 23 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So, now you can count how many number is there. So, you can count up to maximum 10 digits. Unit 10, 100, 1000, 10 lakh, 10 lakhs, crore, 10 crores, 100 crores like this. So, but see, this is a very big number. Okay. So, such a big number of atoms present in the 12 grams of carbon. Is this clear to you? And this number, okay, is called, okay, is also called Avogadro's number. What it is called as? Avogadro's number or Avogadro's constant. It is also called as Avogadro's constant. Okay. So, here mole means what? The number of atoms, the number of carbon atoms, that is C12 atoms, that present in 12 grams of carbon. If we take that 12 grams of carbon, in that how many number of carbon atoms are present, that is called, okay, Avogadro's number, or that is called 1 mole. Okay. So, here you see, Avinash, do you know what is the dozen? What is the dozen? 12. Okay. So, here you know that dozen is equal to 12 quantities, whatever it may be. So, 12 quantities. Okay. So, the meaning is what? If you are taking 1 dozen of apples, for example. Okay. So, the meaning is what? There are 12 apples. Yes or no? Now, for example, if I take 1 dozen bananas, okay, the meaning is what? There are 12 bananas. right? If I take 1 dozen of chocolates, okay, then there are 12 chocolates, yes or no? So this is fixed number. Dozen means what? It is a fixed number, 12 quantities. If you are taking bananas, then it becomes 12 bananas. If you take 12 apples, 1 dozen apples, so it becomes 12 apples. So like this, but dozen means number, that is fixed quantity. Is this clear to you? Right. Now similarly, 1 mole of any substance. So remember, this is very important now. Okay. Similarly, 1 mole of any substance. Okay, any substance contains, okay, contains 6.022 into 10 to the power of 23 quantities. Is this clear to you now? Okay, so 1 dozen means 12, dozen means 12, that's all. Similarly, 1 mole means, if you explain in terms of atoms, 1 mole means 6.022 into 10 to the power of 23 quantities. Okay, so the meaning is what? For example, if you are taking 1 mole of carbon, so how many number of carbons are there? So the number of carbon atoms are 6.022 into 10 to the power of 23. Yes or no? Carbon atoms. Okay. Now for example, if I take 1 mole of oxygen atoms, okay, oxygen atoms. So now there are how many number of oxygen atoms are there? So number of oxygen atoms is equal to, again same, 6.22 into 10 to the power of 23. If I take 1 mole of water molecules, okay, water molecules, how many water molecules will be there now? Same, okay, number of water molecules equal to 6.022 into 10 to the power of 23. Is this clear to you? Is this clear?
Sir, can we say that 1 mole of carbon is 1/12 of
No. That is mass. That will be different. This is we are discussing only about the mole. Mole in terms of number. 1 mole of carbon means carbon contains 6.022 into 10 to the power of 23. That is fixed number. 1 mole is equal to number in terms of number, that is fixed. 1 mole of carbon, if you are taking 6.022 into 10 to the power of 23 carbon atoms. 1 mole of oxygen atoms, 6.022 into 10 to the power of 23 oxygen atoms. 1 mole of water molecules, 6.022 into 10 to the power of 23. So 1 mole means what? That is a fixed number. Is this clear to you? Right. Now let's go to the previous slide. Here I am taking 1 dozen of apple. Number of apples are 12. 1 dozen of bananas, 12 bananas. 1 dozen of chocolates, 12 chocolates. Okay, all 12. Number is same. Remember, number is same. But now, for example, if I check the mass of 12 apples, mass of dozen. Okay, 12 apples, and here mass of 12 bananas. Okay, and here mass of 12 chocolates. Does this mass remains the same? No, the mass will be different. Apples have different masses, 12 apples. Bananas have different masses, chocolates have different masses. Number is same, but mass is different. Is this clear to you?
yes.
Right. Similarly, now when you come to the here 1 mole of carbon atoms means what? 6.022 into 23. Number is fixed. 1 mole of oxygen means what? Again 6.022 into 10 to the power of 23. That is fixed. 1 mole of water molecules not 6.022 into 10 to the power of 23. So here carbon atoms are there, here this oxygen are there, here water is there. Now does the mass of all these atoms remains the same? No. So the mass is different here also. Number only same. Mass is different. Then what is the mass of this? Okay. So the mass of 16 carbon, 6.02 into 10 to the power of 23 carbon atom is how much? So that is nothing but 12 grams. How much it is?
12 grams.
because carbon atomic mass is 12. Because carbon atomic mass is 12. So 12 grams. Is this clear to you? Now, here 6.02 into 10 power of oxygen atoms are there. Now, what will be the mass of oxygen atoms now? You take oxygen atomic mass. What's the oxygen atomic mass? 16. So that's but is 16 grams. Okay. Now, if you take 1 mole of water molecule, so 1 mole of 6.02 into 10 to the power of 23 water molecules are there. Now, what will be the mass of this one now? 18 grams. Very good boy. So 18 grams. Is this clear to you? So when you express the mass, of 1 mole of an atom here, then that is equal to its atomic mass. Means what? For example, 1 mole of carbon, if you are taking, you think its mass is, carbon atomic mass is 12. So 12 grams. So 1 mole of carbon atomic mass is 12. Is this clear to you? Now, similarly, mass of 1 mole of molecule, you think, molecule. So here also its molecular mass. Okay. So the meaning is what? If you are taking carbon, here I am taking carbon atom. Okay. Carbon atom, its atomic mass is 12. So it's equal to this 12 grams. 1 mole of carbon atoms means it contains 6.022 into 10 to the power of 23 carbon atoms, and its mass is equal to 12 grams. Now similarly, if I take the mass of 1 mole of oxygen, 1 mole of oxygen also contains same number, that is 6.022 into 10 to the power of 23 atoms of oxygen, but its mass is 16 grams. Okay. If you take mass of 1 mole of water molecule, then this also consists of 6.022 into 10 to the power of 23 water molecules. Number remains same, but mass is equal to its molecular mass. Water molecular mass is what? 18. So we will be getting the 18. Is this clear to you? Okay. So these are the things. So now you do one thing. You take the screenshot, or better to write this one. So okay, write something this so that we can go further, because very important concept this one. So note down this one. Editana? This one very important. So write, others take the screenshot. Okay, no issue. But later at least you have to write, because very important concept this is. This also you take. This also you take. Right? Okay. Now I am going to give some important formulas based on this one. Okay. So here you see, now we have the right. So now we have these 3 formulas here. These 3 formulas you have to note down. Small n is equal to small m by capital M. Okay, I'll write here one by one. N is equal to m by capital M. Now what they represent? Okay, so n means number of moles. Write this one, you write now. Okay, number of moles. Okay, and small m is equal to given mass. Okay, and capital M is equal to molecular mass. So this is one important formula. right? Now, second formula. Second formula, n is equal to n by n naught. Okay. Second formula, n is equal to n by n naught. So here n is again number of moles. Okay. So small n is nothing but a number of moles. Okay. N is a given number of particles. Given number of particles. How many particles they are given? Okay. Particles. And n naught is Avogadro's constant or Avogadro's number, which is nothing but a 6.022 into 10 to the power of 23 entities, whatever it may be. Write this formula. Written. Now, third formula, m is equal to small into capital N. Okay. So n is equal, that not required, because same n is equal to this. If you bring m is equal to, so okay, we write that also. Third one, n is equal to, no, m is equal to only, so m is equal to n into capital N. Okay. So this also right here. Okay. So m means what? Mass, given mass, and n is equal to number of moles. Okay. And n is equal to number of particles. Right. Now then go to one more formula is also there, n is equal to, not required that formula. Okay, done. Right. So these are the important. So do one thing, you take the screenshot of this one also once. So all will be there here. Taken? Right. Okay now. So here now what we are going to do is, right. Now what we are going to do is, here for example, I will ask some questions to you, simple questions. How many, okay, so some numericals here. Okay. How many helium atoms in okay, I'll write 2 grams. Okay, 2 grams of helium. Okay. So now what they are asking is, how many helium atoms in 2 grams of helium? How can you find out how many helium atoms are there in 2 grams of helium? How can you find? Yes. What is the helium atomic mass? No, atomic mass of helium. Huh? Hydrogen is 1. Mass, atomic mass of hydrogen is 1. Similarly, atomic number of helium is 2. Okay, lithium is 3. Boron is like this or they know. So here, what is atomic mass of helium? 4. Very good. So here 4 grams. Okay. So atomic mass of helium is equal to 4. Yes or no?
Yes.
Right. Now in the previous slides I have given that See here. Mass of 1 mole atom is equal to its atomic mass. What I given? Mass of 1 mole of atom is equal to its atomic mass. The meaning is what? Helium atomic mass is 4. So 4 grams equal to 1 mole. 4 grams is equal to 1 mole. Okay. So if I want to find the number of moles. Okay. Now number of moles of helium I want to find. So number of moles is denoted by which letter? N. And here what is the given mass? Given mass of helium. Given mass of helium. Okay. How much mass is given? 2. Okay. So here you see atomic mass of helium. I am writing with the capital letter M. Okay. Capital letter M is equal to 4. You said that atomic mass of helium is 4, capital M. And number of moles of helium we need to find. N is equal to question mark. Now given mass of helium, given mass is 2 grams is given. We write small m. Small m is equal to 2 grams. Okay. Now first you need to calculate the number of moles. Okay. So for number of moles, what's the formula? Here you see N is equal to small m by capital M. Okay. Now substitute now. So here you substitute now. N is equal to small m by capital M. Small m by capital M. So that is equal to small m is how much? 2 by 4. So that comes to 1 by 2. Okay. 1 by 2, or you can write 0.5 also. 0.5 moles. Is this clear to you? Now we got 0.5 moles here. Okay. Now they are asking in the 0.5 moles how many helium atoms will be there. So number of now see here. Now again go to the previous slide. So here you see. Now if you find the number of particles, what is the formula here? Number of moles into number of particles is equal to, otherwise you can go to this mass and number. So here you can write this one you take. Okay. N is equal to N by N naught. This formula you take. Okay. N is equal to N by N naught. Okay. So here you see now. N is equal to N by N naught. Okay. So now I want this number of particles N. So what can I write? N is equal to this N naught I am bringing this side. It becomes N into N into N naught. Is this clear to you?
Yes, sir.
Now see here N is equal to what I got the N here? N here I got 1 by 2 or 0.5. Anything you can write here. Okay. So what can I write? 1 by 2 I will write. 1 by 2 into N naught means what? Avogadro's number. Avogadro's constant is 6.022 into 10 to the power of 23. Okay. Now you cancel. 2 ones are here, if you cancel 2 3s are 0 1 1. Okay. So our final answer is N is equal to 3.011 into 10 to the power of 23. So the meaning is what? Therefore 2 grams of helium contains 3.011 into 10 to the power of 23 atoms. That's all. It's clear to you?
Yes, sir.
If you want to check our answer is correct or wrong, so you know that helium atomic mass is 4. So already I said that atomic mass is equal to atomic mass is equal to its mole, and one atomic mass gives rise to 6.022 to 10 to the power of 23 molecules. So here 2 grams is helium, contains this one. 4 grams, then you make it to double. Yes or no?
Yes.
So if you make double, what will get? 6.011 into 10 to the power of the atoms. So helium atomic mass is 4. So 4 grams of helium atom consists 6.022 into 10 to the power of 23 atoms. Clear? So once, so from here you can copy this one. Slowly you can copy one by one, step by step. Already done? Chalo, next one also copy. Right. Now, okay, now we'll give one more problem to you. Calculate the number of moles, okay, of 12.044 into 10 to the power of 23 hydrogen atoms. Like this, I give one question to you. Think, okay? Calculate the number of moles. I'm asking to calculate the number of moles. Okay, number of moles. I'm asking here of 12.044 into 10 to the power of 23 hydrogen atoms. So how can you calculate now? So first you write what is given here. So solution. So first you write number of hydrogen atoms is equal to, that denoted by capital letter N, is equal to 12.044 into 10 to the power of 23. This is given. Yes. Next, you know that atomic mass of hydrogen, okay, hydrogen atom means capital M, is equal to 1. Yes or no? Now what you need to find? You need to find the number of moles. Number of moles of hydrogen, okay, atoms. That is number of moles is denoted by which letter? N. N is equal to question mark. Now N, M, M are present in which formula?
Small n is equal to capital N by N naught. That one, second one.
What? Second one is what?
Small n is equal to capital N by N naught.
Capital N by N naught. Yeah, otherwise this is better. Okay, you write this formula, N is equal to capital N by small n naught. Okay, so what is the problem? So now what you do? Okay, n naught, Avogadro's constant, Avogadro's number n naught is equal to, you know that 6.022 into 10 to the power of 23. So which formula you have to apply now? N is equal to N by N naught formula you apply. Okay, so N is number of moles is equal to N. How many number of atoms are given here? 12.044 into 10 to the power of 23 divided by N naught. N naught is given how much? 6.022 into 10 to the power of 23. Now what you do? Cancel. 10 to the power of 23, 10 to the power of 23, both numerator and denominator. Now this 6.022 ones are 6, this 2s are. Okay, so our left is what? Only 2 is left here. So N is equal to 2 moles. Okay, that's all. The answer is asking to find how many number of moles. The number of moles is equal to 2 moles. Is this clear? Right. Completed? Okay then, with this we stop today.